Hello student, welcome back to physics class, and here I am making another video for grade 11. Yesterday I made one video based on this topic, that is our last topic of our fourth chapter, that is motion in a plane, projectile motion, and in that we have studied about the nature of the path in projectile motion, and we have derived one expression, and that expression was the equation of parabola, and that's why we have concluded that our projectile motion will be in the form of a parabola. And now today we will be studying about another part in that projectile motion only, that is flight time of projectile motion, and after that we will be calculating the range also, that what is the length on the ground or on the horizontal axis that a particle is covering while doing the projectile motion. So here everything I have explained you earlier also, that this is the certain angle by which some particle has been projected with initial velocity u, and we have calculated the components. We have calculated different components along the horizontal and vertical direction. And as you people might be knowing that we have calculated the component along x in terms of u, and that came out to be cos theta naught, u cos theta naught. Similarly, uy we have calculated in terms of u sin theta naught. So in terms of angle and in terms of the initial velocity at certain angle, we have calculated these components. So flight time of the projectile motion is the time which the particle takes to cover this entire projectile motion, starting from here and ending till here. Okay, so flight time of a projectile motion, for that we will be again applying few equations of the motion that we use for constant acceleration, that we have already studied. And so first we are required to calculate the time of a particle, that how much the particle takes to reach from O to P. Let us assume that height is supposed to be that time is supposed to be small t. Okay, I am assuming the time taken by the particle from this point O to this point P is small t, and again the same time will be taken by the particle to cover the distance from this point O, point P to point O dash. Okay, so time taken from O to P will be equal to the time taken from P to O dash. Okay, because we are applying what? We are applying the condition of constant acceleration, and that's why we are using the equation of motion here. So for a particle starting from zero height from the horizontal level to reach this height, that is the maximum height, you can see it is represented by h. Okay, so particle is taking some time. So for that we will be using the first equation of motion, that is v is equals to ut, v is equals to u plus at. But here in this case, what we need to include, which is very important, is that instead of v is equals to u plus at, now in place of a we will be replacing that a with minus g, and let us see that what is the value which will be coming. So finally at this point, what will be the value? The value will be equal to how much? The value will be equal to 0, because finally after reaching this height the particle has a 0 velocity. Okay, the particle has the final velocity which will be equal to 0, and after attaining the 0, again it started its journey, and again it has some velocity in the downward direction. So which component of the velocity, which component of the initial velocity is responsible for the particle to carry that particle from this 0 level to a certain height? Obviously, out of these two components, the second component, that is the uy component, will be responsible. That is the vertical component, because we are talking about some vertical height. Okay, so at this point, at this point, the contribution of the velocity will be uy. Okay, that will be there, which will be responsible for the particle to gain some height. So now applying the first equation of motion, and at this point I am assuming that the particle has a final velocity of 0. So 0 is equals to, that is v is equals to u, that is q sin theta naught plus, or in case of what, in case of plus we will be using what, minus of g into t. Okay, this is the value which we will be using here, and we already know we have to calculate this t time. We are required to calculate this t time now. In this case, what is t? Here in this case, the t is the time required for a particle to cover the distance from O to P. So that time we will be calculating here. So for calculation of that time, let's see. So t comes out to be q sin theta naught upon g. This is what the time we will be getting from here. Okay, and if we just double this time, if we just double the time, then we will be knowing the entire time which a particle will take to cover this entire projectile motion from here point O to point O dash. That will be the flight time of the projectile motion. Okay, so the total time, let us denote the total time by capital T, and that T will be equal to 2 into T, and this will come out to be 2u sin theta naught upon g. So this will be the actual time which a particle needs to cover certain length, certain range. Okay, so this is the required flight time of the projectile particle that we have derived, and this formula is very important for every student to learn, because on this basis only we will be solving different numericals. So we can analyze that at different values of theta, the time also varies. That is, the flight time also varies. For example, in which case we can say that total time taken by the particle in covering the projectile motion will be maximum. So for a time to be maximum, the function of theta, that is sin theta, should have its maximum value. Okay, so for that case what we will be doing? We will be putting, in place of theta, we will be putting what? We will be putting theta is equals to 90 degree. That means we have to project in that case at which angle? At perpendicular direction. Okay, in that case the projection will be in the perpendicular direction for time to be maximum. Okay, so in this case a person should throw with some initial speed at 90 degree with respect to this horizontal axis. That means in this direction. So in that case theta will be maximum and sin theta will be 1, and in that case the time will be maximum, that is 2u upon g will be that case. Okay, so now we will be calculating another parameter, that is height of the projectile. Okay, we have calculated the time here, and now we will be calculating the height, that what is the height which a particle has reached during its projectile motion. So for height, now we will be using the third equation of motion, that is v square is equals to u square plus 2as, that we have already studied. Now in case of the particle when it is going in the upward direction, then what we will be knowing, we will be replacing that a with minus g, that is acceleration due to gravity. These all things we are knowing. Okay, and we have to replace this s. Okay, यहाँ पे we can write like this: v square is equals to u square plus 2as. So s is what? S is the magnitude of displacement. So this s is certain length, and here in this case for height, the certain length is what? Height, that a particle is covering a certain height from 0 level to a certain h level. Okay, this is the h level of height. So in place of s, we will be replacing this by h, and here a is replaced by g, that is acceleration due to gravity, with negative sign. And now we should understand one thing more, that after reaching this height, the final velocity, that is the vertical component of the velocity, becomes 0. Okay, so in that case this value will become what? This value will become 0, that is the final velocity term. And which component, again the question arises, which component of this u is responsible for a particle to carry that particle from 0 height to certain height? So obviously we can conclude now the only component what? The vertical component is responsible for a particle to carry it from the zero level to a certain height. So what we can write? We can write the 0 is equals to u sine of theta naught. That is the vertical component. I am using uy. Okay. So u square minus 2gh. This is what we can write. So from here h can be written as u sine theta naught upon 2g. This is what we can write. This is the height which a particle can attain. Okay, this is the height which a particle can attain during the motion. During the motion. Okay, here we have to do the square. That comes out to be u square and sine square theta naught. Okay, this much the value will come. So this is the value of height which a particle has to attain during by covering in case of projectile motion. Okay, so now what we can do? We can express this value of height by changing the value of theta again. Okay, by changing the value of theta again, we will be expressing the value of the height. Okay, so in which case we can conclude the height will be maximum? We can conclude that the height will be maximum in that case when theta will be what? Theta will be equal to 90 degree. When this sine square theta will become 1, in that case only the value of the height will be maximum. That is again in case of projectile motion, when we project our particle at 90 degree angle with respect to that horizontal axis, then we can say that height comes out to be u square upon 2g in that place, because this sine square theta term will become 1. Okay, so this was the expression which you have to learn to solve the numerical. That is the expression of the height of projectile. Okay, this is the expression of height of the projectile. Now the very important expression we are going to discuss, that is the range of the particle. Okay, range of the projectile. What will be the range of a projectile? That means we will be talking about this length, that how much length a particle will cover in case of doing the projectile motion. Okay, so range, we can decide the range again by the help of using the displacement, velocity and time parameter. As while discussing the path of the projectile motion in the previous video, we have applied the formula for range, that is range corresponding to x-axis, and from there we have calculated the x in terms of the component of the velocity along x direction and time. Similarly, here also this range is what? This range is corresponding to the horizontal direction. And let us write down first of all the heading, which is that the range of projectile. Range of projectile. So range of the projectile will be how much? That is denoted by capital R, and that is nothing but that is the horizontal displacement of the particle from this point O to point O dash, and that will be equal to the component of the velocity into this direction, into the horizontal direction, and that will be u cos theta, because it is the component of the velocity in horizontal direction. That is u cos theta naught into, this is velocity into displacement is equals to velocity into time, and here we have to take this entire time, flight time that we have calculated, that is capital T, not this half time, this full time, that is 2u into sin theta upon g, 2u sin theta naught upon g. This is what we have to write. Okay. So what we do? We again do the simplification in this expression, and after doing the simplification we can write that r is equals to u square 2 sin theta naught cos theta naught upon g. This is what we can write. And you can see that this 2 sin theta cos theta is the formula of sin 2 theta. This we know very well according to the knowledge of trigonometry. And r comes out to be u square sine 2 theta naught upon g. This is the value which we will be getting for range, and this range value is also very important that we have to learn, okay, to solve the questions which we will be getting now. Okay, so again we can apply different conditions. That what will be the maximum value of this range. Okay, so we can conclude that if theta will be equal to what? How much? Theta will be equal to 45 degree. So in that case, the value of this sine 2 theta will be maximum. Okay, that will comes out to be 1. And in that case, the maximum range will be getting. That means we have to project the particle at an angle of 45 degree with respect to the horizontal to get the maximum range, to get the maximum length to cover our particle, okay, on the ground level. So in that case, we can write the R max, that is maximum range, for theta is equals to how much? 45 degree, because 45 into 2 will become 90, and sin 90 has the maximum value that is equals to 1. That will come out to be u square upon g. Okay. So this was the value for maximum range. So for different values of theta, we can analyze that what will be the height of a projectile motion, what will be the range of a projectile motion, okay, what will be the time in that case the particle will take to cover the projectile motion. So these were the conditions that we have discussed about the projectile motion. Okay, thank you.